All right, so this is our last equation, our last problem. Find all the solutions to the system. So again, we're going to do this exact same thing as we did last time. So first, you're going to look at your equation and pick a variable to eliminate. And I'm looking, and I want to eliminate the y's, I think. So that's the one I'm going to go with. So row 1, I'm going to label my rows. This is row 1, row 2, row 3. So 1 and 2, if you add those together, those y's are going to cancel out automatically. So I'm going to just do row 1 plus row 2. And that gives me x minus y plus 5z equals negative 2. 2x plus y plus 4z equals positive 2. Add those together, 3x, your y's are gone, plus 9z equals 0. So I've used row 1, I've used row 2, now I have to use row 3. You can either, I guess it'd be easier to do row 2 minus row 3, or, oh sorry, we're doing the y's. I'm going to do 4 row 1 plus row 3. So 4 row 1 plus row 3. So I have 4x minus 4y plus 20z equals negative 8. Make sure that you multiply through to everything. You don't forget to multiply the last one. And then 2x, 2x plus 4y minus 2z equals 8. So 6x, your y's are gone, plus 18z equals 0. So now I have my new row 1 and my new row 2. Come on. Now you can eliminate either variable. I'm looking at them and it's the same line, right? It's the same thing. So I'm going to do negative 2 row 1 plus row 2, negative 6x minus 18y, z equals 0, 6x plus 18z equals 0. I get 0 equals 0. True statement, right? So that means I have infinite solutions. If you think about this, if you look at it, row 2 and row 3 are going to be the same plane, right? No. Nope, they're not. Never mind. Okay, so when I did this, they eliminated completely, and they got 0 equals 0, which means I have infinite solutions. So if you think back about our thing, when you have infinite solutions, that means these planes are going to intersect in a line, right? So I need to figure out what the relation is between all of these to make that intersection where they are all three intersecting, to figure out the coordinates that I could plug in to get all the answers. So to do that, kind of our steps, you're going to pick a row 1. So step 1 is pick a row 1. It doesn't matter which one you pick one that looks easy. Then you're going to pick a row 2 that only has 2 variables. So we're kind of going into like a triangular form like we did before. So if you remember, we'll go way back up here. Triangular form, you have a row 1 with 3 variables, a row 2 with 2 variables, and then a row 3 with 1 variable. So after you pick a row 2, you're going to solve that row for either variable. Once you solve it for either one of the variables, you're going to let the other variable equal t. And then your last step is back substitution. Okay, so pick a row 1. So let's go up here to our original, pick a row 1. I think that the original row 1 looks like a good row 1. That one looks the easiest to deal with to me. It really doesn't matter which one you pick though. So pick a row 1. X minus y plus 5z is my equals -2. That's my new row 1. Pick a row 2. So I'm going to choose from these, like my little second tier equations, choose from those for a row 2. I'm going to choose the one with the smaller numbers, 3x plus 9z equals 0. Solve row 2 for either variable. Okay, so I want to solve it for x probably so that I don't have fractions. So if I solve it for x, I get 3x equals -9z, x equals -3z. So I've solved it for one of the variables, and now let the other variable equal t. So I solved it for x, so that means I'm going to let z equal t. So it doesn't, like I said, have said over and over, it doesn't matter which one you do. I could have solved for z up here on this step. I could have made 9z equals -3x, then divide by 9 and have 1/3, and that would still work. You just have to substitute fractions in. So I try to get it to where I don't have to substitute in fractions, because remember, we're going to have to back substitute and then back substitute again. And fractions are just harder to substitute in and manipulate. So if you can do it without having fractions, it would be easier. But that's not always the case. You can't always do that. So now I'm going to use back substitution to get my x in terms of t and my y in terms of t. So if I have z equals t, then I have 3x plus 9t equals 0. 3x equals -9t, x equals -3t. So I have my x now. I probably smarter would have been to plug it into this one that I'd already solved for, but I didn't. So, but notice it's the same answer if I would have put the t in there. And then I look at my original equation, my top equation. So I've back substituted into here. Now I'm going to back substitute into here. So I have 3 times -3. No, just how about -3t? So into the top equation, -3t minus y, we don't know that yet, plus 5t equals 2. So 2t minus y equals 2. -y equals -2t plus 2. So y equals, I lost the negative. It's a minus. Y equals 2t plus 2. So my solutions, all the solutions to this equation are -3t, 2t plus 2, and t. So I can plug anything in for t and get the other two coordinates for all those points along that line where the planes intersect. All right, so that's it. I know that these last finding all solutions when it's an infinite number of solutions is a little bit harder, and it's something you probably have never done before, but just follow the steps and practice and you'll get it. All right.